Hey, what's up everybody? My name is Coach Anderson, and in this video, we're going to talk about Unit 3, Force and Motion. We'll begin by exploring the various types of forces, and then we'll dive into how we can calculate for net force. Lastly, we'll discuss Isaac Newton and his third law of motion. Go ahead, have a seat, and hopefully you learned something new from this video. All right, let's go ahead and get started by talking about some key vocabulary words that I think you need to know. The first word is force, okay? And when you think about the word force, you probably think of a push or a pull. Good examples of forces could be when I push a door closed or I pull the door open. Now there's various types of forces that we'll discuss, and we're going to begin by talking about contact and non-contact forces. A contact force is any type of force that requires that objects are in direct contact with each other, right? Direct contact means touching. So if I push a box, right, that would be a contact force. On the other hand, we have non-contact forces. Non-contact forces do not require objects to be in direct contact. Now, a vocabulary word that you may have heard before is friction. Now, friction is a contact force between two surfaces when they push or rub up against each other. It is parallel to the surfaces and opposes their motion. All right, you may think of a good example of friction as when you rub your hands together. Another example of friction that I'm going to put up on the screen here is a video of me skiing from a while back. Now notice as I ski down this hill, right, I can go semi-fast, right? That's because there's not a lot of friction occurring between my skis and the snowy hill. But if we change the snowy hill to be a grassy hill, what would happen is probably a lot different. I'd probably tumble down the hill, or I would go much slower. And that's because the grassy hill would have much higher friction as compared to the snowy hill. Okay? So now you know a couple different types of forces, and you know what friction is. Let's go ahead and see if you can identify in the next picture which one of these surfaces has the highest friction and which one of the pictures depicts the lowest friction. Go ahead and give it a shot. All right, I'll give you a second to see if you can get this right. You're thinking in your brain which one of these pictures has the highest friction, which one has the lowest. I'll give you about 5 more seconds. 3, 2, and 1. All right, let's see, were you right? Maybe you were right. Okay, if I pull the sled on a gravel-like rocky surface, that's going to have much higher friction. If I pull a sled on an icy surface, it's a lot more slick or slippery, so it's going to have a lower friction. It's going to be easier to pull. The forces that are rubbing against each other, the ice and the sled, right, it's pulling a lot easier. It's going to require a lot less force for me to pull the sled on ice than it would for me to pull the sled on gravel or wood. All right, what is gravity? Well, when I jump over the screen and I come back down to the ground, all right, that's gravity. That's the force that's pulling me down to the ground. Gravity is a non-contact force that pulls objects with mass toward each other. Gravity is also the force that pulls us down to Earth. It's what keeps you and I from floating away up into space. Now, gravitational force is affected by the mass of the objects and the distance between them. The greater an object's mass, the greater the gravitational force between it and other objects. Gravitational force decreases as the distance between two objects increases. Okay? So to recap, gravity is the force that pulls us down to Earth. All right, what is magnetism? Well, magnetism deals with magnets, right? It's kind of part of the word, okay? Magnetism is the attractive or repulsive force exerted by magnetic materials. It's a non-contact force, right? It does not require direct contact. And the magnitude or strength of magnetic force decreases as the distance between the objects increase, all right? As the objects get further away, right, the magnetic force decreases or gets lower. Now, what you need to know about magnets is magnets have two sides to them. They have a north and south pole. Now, when I say North Pole, I don't mean where Santa Claus lives, right? I just mean it's a side of the magnet. And what we might remember from class is that opposites attract. So the North and South Pole attract each other, whereas if they're the likes or the similar poles, the same, right? The North and the North or the South and the South, they don't attract to each other. They repel, okay? They're repulsive, they repel. That means they go further away from each other. So opposites attract. The North and South Pole are going to come closer together, whereas the likes or the same ones repel. They get further apart. Another question I have for you is, what are normal forces? Okay, well, to know what a normal force is, you have to know the opposite, which is an applied force. An applied force is a force that's applied to an object by another object. All right. In class, we talked about if I were to push something or somebody away from me, that's an applied force because I'm directly applying a force to that object or that person. On the other hand, we have normal forces. Normal forces are any type of force that's applied perpendicular to a surface. All right. The word perpendicular, which you might know from math class, is the opposite of parallel. Parallel is when lines never cross or never touch. On the other hand, we have perpendicular. These are two lines that intersect, and where they intersect, they form a straight line, and there's a little box that says it's 90 degrees. Okay. In the picture, what you might notice is there's a car on a road. And as the car's on the road, there's a force being applied downward, there's a force being applied upwards, okay? And that's an example of a normal force, right? There's a straight line being formed there. It's perpendicular. Another good example of a normal force is if we have a book of some sort and it's sitting on a desk, all right? There's a downward normal force applied onto that book that holds it to the table or the desk. All right, as promised, I told you we would talk about how we can measure forces. And before we do that, you kind of have to know the difference between balanced and unbalanced forces. And I think you already know the answer to that, right? Remember when we played tug-of-war in class? I'll show a video here, okay? As we played tug-of-war, we talked about the difference between balanced and unbalanced forces. We said that two forces acting on an object that are equal in strength and opposite in direction are balanced forces. Two forces that are not equal in strength or opposite in direction are unbalanced forces. So hypothetically, if we're playing tug-of-war and both sides pull with the same amount of force, there's no movement. The net force is 0 newtons, all right, and it's balanced. But when we play tug-of-war and one side pulls with more force than the other, it's unbalanced, all right? There's movement. You're going to move one way or the other, okay? And that's an unbalanced force. All right, let's take a second to talk about what net force is and how we can calculate it. Now, net force is the combination of all the forces that are acting on an object. If the forces act in the same direction, like you see in this picture, then the net force is the sum of all the forces, right? That means we add. So in this picture of the dogs that are both pushing on the bag of treats, we add those two numbers together to get the net force because it's going in the same direction. So for this example, we do 18 plus 12, which gives us 30 newtons. Now that N stands for Newton, and a Newton is a unit of measure for force. Now, one thing that you should know is that if the net force is 0, it means that it's balanced. There's no movement. However, if the net force is not 0, okay, it could be 1, it could be 6 billion, okay? If the net force is not 0, okay, then it's unbalanced. And that means there's going to be some sort of movement, okay? Now, on the other hand, if the forces act in opposite directions, we subtract to find the net force. So in these two examples, you see that we're subtracting in each to get the net force. For the dogs that are both pushing on the bag of treats, we do 12 minus 12, which gives us 0. Because the net force is 0 newtons, that means that there's going to be no movement. That bag of treats is not going to move. However, in the other example, you see somebody dropping a soccer ball downwards. There's an upward force of 6 newtons and a downward force of 5 newtons. We subtract those two numbers because they're going in opposite directions, and we know that 6 minus 5 gives us 1 newton. Okay, so the net force for that example would be 1 newton downwards. Okay, now I want you to take a moment and see if you can calculate the net force for these 3 examples. Go ahead and pause this video, give it a shot, and then I'll go ahead and put the answers up in just a second. Once again, right, if the forces are going in opposite directions, we subtract. If the forces are going in the same direction, then we add. All right, go ahead, pause, and try. All right, and here are the answers. Go ahead and see how you did. All right, there's the story about some old guy named Isaac Newton, and the story goes something like he's sitting under an apple tree and an apple falls on his head. And he comes up with this idea of gravity, right? That force we talked about earlier, that force that pulls us downwards to Earth. Okay, so Newton gets hit in the head with an apple. He comes up with, gravity and all that. And he also puts out 3 laws, right? There's 3 things that we learn from Newton. And of these 3 laws, right, what we're going to talk about in this class is his 3rd law of motion. Okay, so Newton has 3 laws of motion, and we're going to talk about his 3rd law, all right? Número 3. Okay, so Newton's 3rd law of motion states that if one object exerts a force on another object, then the second object exerts an equal force on the first object in the opposite directions. Okay, that's a lot, I guess, right? For every action, there's an equal and opposite reaction, okay? The action-reaction forces described by Newton's 3rd law are known as force pairs. So for every action, there's an equal and opposite reaction. If I were to kick a ball, right, as I kick the ball pushes back at my foot with an equal and opposite reaction, okay? Another example, right, might be a balloon. Okay, if you blow up a balloon, when I let it go, right, there's going to be 2 types of forces, right? There's 2 forces going in opposite directions. One's going to go that way, one's going to go that way, and my balloon is going to go somewhere else. Okay, so there's 2 different forces, right, going in opposite directions, right? Every action, there's an equal and opposite reaction. Thanks for watching today, everybody. Hopefully you learned something new about force and motion. If you have any questions, feel free to email me or come to academic coaching. I'm here to help you be successful. Have a great rest of your day, and I will see you in class.